Hello again, how are you? Hope you're doing fine. This week we will be talking about triangles. In this lesson, students will identify and classify triangles using sides and angle measures. We will be talking about acute triangles, right triangles, obtuse, equilateral, isosceles, and scalene triangles. Polygons can be described and classified by their sides and angles, including triangles. The angles of a triangle can form a straight line so that the sum of the measure of the angles is 180 degrees. A triangle. What is a triangle? First, it's a three-sided polygon. So it's a polygon with three sides. It's a closed shape that's made up of line segments. Line segment AB, line segment BC, and line segment AC. So these line segments are called the sides of the triangle. So we have three sides in the triangle. Also, each two line segments, they intersect at one point, and this point will be called the vertex. Let's say point A, which is the intersection of line segment AB and AC. The point A, it's called the vertex, and AB and AC are called the sides. The plural of vertex is vertices. So when we talk about the three of them, the 3 points, point A, point B, and point C, we call them vertices. And of course you can see that at A, it's called the vertex of the angle. You have an angle formed at point A, at point C, and point B. So in all, a triangle has three angles, three sides, and three vertices. The angles are angle A, angle B, angle C, and the sides are the segments AB, segment AC, and segment BC, and the vertices are point A, point B, point C. Like we said at the beginning of the lesson, the sum of the angle measure of any triangle is 180 degrees. So this means that if I give you the measure of the angle A, angle B, and angle C, I have 56 degrees for B, 64 for A, and 60 for C. And if I'm going to add them all, I will have, if you add 56 plus 64 plus 60, you will have 180 degrees. Since the sum of the three angles, the sum of the measure of the three angles inside the triangle is 180 degrees, then if they give me this triangle, for example, I need to find the missing angle, the measure of the missing angle. I have two methods I can use. First, using equations, I will say that the sum of the measure of the three angles will be equal to 180 degrees. So x plus 112 plus 49 equals to 180. Here I'm solving this equation, but before solving this equation, let me add the 112 plus 48, sorry, plus 49. 112 plus 49, which is equal to 161. Now I have an equation to solve. Remember, solving an equation, I do the inverse operation. So because here you have x plus 161, I need to do minus 161, but I need to do it, excuse me, I need to subtract 161 from both sides of the equation. Plus 161 minus 161, they cancel each other. And then 180 minus 61 will be equals to 90. That's the first method. So x is the missing angle equals to 90. The other method, if you don't want to go through the equations, I'm going to use the other method in the other triangle. It's very simple. You add the given angles, two of them, and then you subtract the answer from 180, because this is exactly what I did in the first part. So you add 48 plus 47, 48 plus 87. Okay. Here 8 plus 7 is 15, so this is 5. And then here 8 plus 4, 12, 12 plus 1, 13, so this will be 135. So you add them. Just basically what I did here, so here also I added them. Anyways, and then the answer, I will subtract it from 180 in this case. So I will subtract the answer from 180. So 180, 0 minus 5, I cannot, so this will be 7. And this will be 10. Sorry for my handwriting. Now 10 minus 5, it's 5. 7 minus 3, it's 4. 1 minus 1, it's 0. So the answer is 45. So the missing angle is 45. So these are the two ways. Either I will do the first method here, which is I write an equation, and these are the steps. Or the second method, I add the angle, the measure of the angles given, which are 2. I add them and then I subtract the answer from 180. I got x equals 45. To classify triangles, I have to classify triangles either by looking at their angle measures or by their sides. When we talk about angles, classifying triangles by angles, remember the sum of the angles inside a triangle is equals to 180 degrees. So the sum of 3 angles will be 180 degrees. This means that there is no one angle that's going to be equals to 180 degrees, because in this case the other two will be zeros and this will not be a triangle. So the angles inside any triangle, they can be either obtuse, acute, or right angles. They can never be obtuse, so they can never be straight angles. Anyways, so the first option that we have is that either the 3 angles, they are acute, which is possible, or if one of them is right, you cannot have 3 angles right, because if one is right, then the other 2, they must be acute. Why is that? Because if one of them is right, which means 90 degrees, then the other 2 will be also 90 degrees, because their sum must be 180 degrees. So 2 angles that measures 90 degrees, then each one of them will be less than 90, obviously, so they're going to be acute. Anyways, let us start when you have an acute triangle. An acute triangle, it's an angle with all acute angles inside this triangle. So all angles are acute angles. Remember, acute angles, that means that their measure is less than 90 degrees. They can be from more than 0 degrees, less than 90 degrees. Just like in this case here, you have here 30 degrees, it's acute. 80 degrees, it's acute. 70 degrees, it's acute. So all of them are acute angles. So this I can call now the triangle, acute triangle. This is another example. You have 80 degrees acute, 55 degrees acute, 45 degrees acute. So this is called an acute triangle. So an acute triangle is a triangle with all angles are acute angles. Then if I have an acute triangle, then I must have something called right triangle. Remember, a right angle has a measure of 90 degrees. So in a right triangle, you must have you must have only one angle that is a right angle. And the other 2 angles, they must be acute. Remember, because I told you their sum must be 180. So remember that a right triangle, it's made up of one right angle. And the right angle has this sign here, the square corner. Remember, always remember this. I could write 90 degrees, or I can show you this sign here. This shows that this is a right angle. Because this triangle has one right angle and the other 2, of course 45 and 45 are acute, then this one, it's called a right triangle. The other example is correct also. You see here, you have, this is the right angle sign, and this is 60 and 30, which both of them are acute. So this is a right triangle. I cannot have 2 right angles inside the right triangle or more, because if you have 2 right angles, then you have 90 and 90, which the sum is 180, then you have a 0 degrees angle in the third one. So no, this is not possible. We cannot make a triangle out of these angles. So we're done with acute triangle, we're done with right triangle. Now this is another example of a right triangle. Sometimes you don't need the measure of the other angles to know that this is a right triangle. Enough to show one angle that is right, it will be a right triangle. Obtuse triangle. Obtuse triangle, of course, obviously must have one obtuse angle. And obviously the other two, they should be acute angles. I'm going to give you an example in here. Here you have 180 degrees. 110 degrees, this is an obtuse angle, obviously, and 25 and 45 are acute. So this one is called an obtuse triangle. So an obtuse triangle has one angle that is obtuse angle, and the rest are acute. This is another example where you have here the 100 degrees is an obtuse angle. It's enough to show the obtuse angle. It will be called an obtuse triangle. Now, another way to classify angles, it's not only by looking by their angle measure, we are going to look by their sides, the length of their sides. Actually, when you have three sides, then you have three options. The first option, all the sides are not congruent to each other, they don't have equal measure. The other option, that all of them, they have equal measure. And the third option is that two of them are equal, but not equal to the third one. So I have here three cases. I will start with the one where all sides, they have equal measures, or all sides are congruent, like this case here. And this one, I call it an equilateral triangle. Remember that these symbols are very important. This thick thing here, it shows congruent segments with this one and with this one. So this means here that the segment EG and the segment GF and the segment EF are congruent. Congruent means they have equal measures. So that's why it's an equilateral triangle. Remember also one thing, and this is a very important idea in triangles. When you have three congruent sides, then obviously you're going to have three congruent angles. So in this case here, this is a congruent, this angle congruent to this angle, and angle G congruent to angle E, congruent to angle F. This is always the case. So equilateral triangle, it's a triangle that has all sides congruent, all sides congruent, yani they have equal length. All angles are congruent, also they have equal measures. And if they are all of them congruent, then each one of them will be 60 degrees, because 60 times 3 equals 180, and 60 plus 60 plus 60 equals 180 degrees. So an equilateral triangle, all sides are congruent, all angles are congruent, and all of them are acute because they have a measure of 60. So an equilateral triangle is always also an acute triangle. This is another example. You can either see the ticks that shows congruent segments or congruent sides, or you can find the measure 5 centimeter, 5 centimeter, 5 centimeters. So these have equal measures or congruent sides, and the angles are 60 degrees, 60 degrees, 60 degrees. So this is an equilateral triangle. This marks indicates the equality. So this is an equilateral triangle, this is an equilateral triangle, this is an equilateral triangle. Now, the other case, when you have two sides congruent and two angles congruent, as you can see in the figure, but not congruent to the third side or to the third angle, this is called an isosceles triangle. An isosceles triangle, it's a triangle that has two sides, they have the same length, at least two sides they have the same length, and two angles have the same measure. So this is an isosceles triangle. This is also an isosceles triangle because, as you can see here, it shows the sides are congruent. So you have two sides are congruent, and you have two angles are congruent. The same thing here, two sides, side AB congruent to side AC, which are equal. Their length is 5 centimeters each, but side B. Okay, this is part 2. We will continue by classifying triangles by sides. And now we reach the isosceles triangles. Isosceles triangles, they are the triangles that they have at least two sides with the same length and two angles have the same measure. These are examples of isosceles triangles. If you see in the last one, the third one here, AB is congruent to AC because each one of them has a length of 5 centimeters, but they are not congruent to BC because it has a different length. So this is an isosceles triangle. Remember that angle B and angle C are also congruent. That's it. The third case, which is, these are all examples of isosceles triangles. The third case, which is that called scalene triangles, when you have a triangle with no sides have the same length and no angles have the same measure, like this one shown in here or the other one. The length of the sides are 9, 13 and 14, so none of them are equal to each other, so this is called as scalene triangles. Or even the measure of the angles 55, 45 and 80, we don't have congruent angles or congruent sides, so this means that it's called a scalene triangle. Okay. Even though I want to point one thing, now we're gonna later on be classifying triangles by angles and by sides. If we look at this triangle here, all of them are acute angles, so this one I can call it acute and scalene. However, this one here, one of them is obtuse, which is 110 degrees, so I can call it obtuse and scalene. So we need to classify by sides and by angles at the same time. For example, the third one here, it's given, it's right and scalene. In short, this is the page from your book. We can classify triangles by their angles. So you have acute triangle, all angles are acute angles. Right triangle, one angle is a right angle. Obtuse triangle, one angle is an obtuse angle. We can classify triangles by their sides. Equilateral triangle, 3 ticks, you see all sides are congruent. Isosceles triangle, at least 2 sides are congruent. Scalene triangle, no sides are congruent. What we have to do in this lesson is that we have to find the missing angle inside the triangle and then classify the triangle by sides and by angles. First, to find the missing angle inside the triangle, I told you we have 2 ways. Either we use the equation, I'm going to use the equation in one part and I'm going to do it directly in the other part. To find the missing angle, so I'm going to write the equation. Remember, the rule says that the sum of the measure of the angles inside the triangle equals 180 degrees. So x plus 50 plus 70 equals 180. I add 50 plus 70, I will end up having 120. In this case, I need to do the inverse operation to get x alone or to find the value of x. So I will do minus 120 minus 120 both sides. So I will end up having x on the first side and on the second side 180 minus 120 equals to 60. So I found the missing angle 60 degrees. Now I need to classify the triangle by angles and by sides. Now by angles I need to look at it. You have 50 degrees, 70 degrees and 60 degrees. So all of them are acute. So this means that this is an acute triangle. If we look at the sides, we see that also you have no congruent sides. So this one is called scalene, or even no congruent angles because the angles are different and the sides are different. So this one is called a scalene and acute. So when I talk about the angles, it's acute. When I talk about the sides, it's a scalene. So this one is acute scalene triangle. If we look on the other side, I need to find x first. Okay, I need the other method. Instead of writing it as an equation, I will add 102 plus 54. 102 plus 54. You add, so you add the angles given, the measure of the angles given. So this one's going to be 6, and this is going to be 5, and this is going to be 1. Okay. After that, I will subtract the answer from 180. So now here the 8 will be 7, and then the 0 will be 10. I'm sorry for my handwriting. So this will be 4. 7 minus 5 will be 2. And this will be 0. So x will be 24. So x will be 24. Now, if x is 24 degrees, then if we look at the angles, you have 24 degrees, 54 degrees, and 102 degrees. So obviously 102 is obtuse, so this triangle is an obtuse triangle. But you don't have equal angles or equal measures of the angles, so it's scalene. Remember, when I don't have congruent angles, this means I don't have congruent sides. So here, no congruent angles means no congruent sides, means it's a scalene. Because one of the angles is 102, so this one is called obtuse scalene triangle. We move on. In this case here, the same story. I need to find the missing angle. Obviously, you should know that 3 sides are congruent. This means 7 inch, 7 inch, 7 inch. So this means 3 angles must be congruent. So x must be 60 degrees. And this one is called equilateral because it has 3 congruent sides. And all of them are 60, 60, 60. So this one is obviously acute. If we want to do it the long way, we do 60 plus 60, 120. I subtract 120 from both sides. I will end up having 60 degrees. As we said, 60 degrees, 60 degrees, 60 degrees. So it's called equilateral because all of them are congruent, and it's acute because all of them are acute angles. The figure to the right, remember that the square corner, it's a 90 degrees angle, so it's a right angle. So when you're gonna add it with a 90. Remember that. So now 35 plus 90, this will be 5, and this will be 12. So I add the measure of the angles given, and then I will subtract it from 180. So 180 minus 125, this will be, of course, 7, and this will be 10. Now 10 minus 5 is 5, 7 minus 2 is 5, 1 minus 1 is 0. So the measure of the angle missing is 55. So 55, 35, and 90. If we look at the, if I'm going to classify by angles, you have one right angle, so this one is called the right triangle. If I classify by the sides, since I have no congruent angles, this means I have no congruent sides, so this one it's a scalene. So this is scalene and right, so right scalene triangle. Another example, this is obviously a right triangle on the left side, but I still need to find the missing angle. So you have 90 degrees, 45 degrees. So x plus 90 degrees plus 45 degrees equals to 180. I find it. I add 45 plus 90, which is 135, and then I will subtract them from 180. I will get x equals to 45. In this case, this is an interesting triangle. You have here the measure of one of the angles is 90 degrees, and the other one is 45, and this one also is 45. If I want to classify the triangles by angles, you're going to have 90 degrees. So you have right angle, so this means it's a right triangle. Because I have two angles that they have equal measures, then this must be an isosceles. So this one is right isosceles triangle. Remember, an isosceles triangles, it has at least two congruent angles or two congruent sides. The third one, also, I'm gonna find x by adding 76 plus 52, and then the answer I subtracted from 180. I'm using different methods. You can use any method you want. So this will be 6 plus 2, it's going to be 8, and then 5 plus 7 equals 12. And I'm gonna do 180 minus 128, so this will be 2, because this is 10 and this is 7, so this will be 5, so it will be x will be 52. When x is 52, okay, so now you have here this angle is 52 degrees. If I want to classify by angles, you have 76 acute, 52 acute, 52 acute. So it's an acute triangle. But if I look at the sides, since I have two congruent angles, this means you have two congruent sides. So this one it's isosceles. So this is isosceles acute triangle. Okay, I'm done. Thank you.